Are there any questions about anything at all? I'll be talking about the exam in a bit, so that those questions should probably wait. But anything else? Okay, if there's no questions, let's go and take a look at the quiz. Okay, so here's the quiz. And the first question on the quiz is find the Taylor series for f of x equals 1 minus 2x to the 3/5 power. Okay, so what kind of function is this so that we can work on the Taylor series? In one word.
Binomial.
Yeah, there's a binomial. And notice that it's 1 minus 2x, not 1 minus x, but that we can handle. In fact, it might even be helpful to grab this, just a minute. It won't let me grab it, so I'll retype it. And that is f of x equals 1 minus 2x to the 3/5. And rewrite this with f of u equals 1 minus u to the 3/5. And it'll look like a binomial. Sometimes it helps to just change the letter a bit. And then there is a formula for, and actually it's, sorry, it's not 1 minus, it's 1 plus. Because in the binomial, you want a 1 plus x or 1 plus u, the letter doesn't matter. So then you got to remember the binomial expansion. And who remembers how the binomial expansion works? So let me write that out. So that was in general, and I'm going to use u instead of x just because we've got u. And that is 1 plus u to the 3/5 equals, what's the first term? Into this pretty easy. What's the first term in the binomial expansion? The very first term.
U.
The very first term is 1. Okay. Yeah, the first term's 1, right? Okay. And note, by the way, if u is 0, then you just get 1. That's the reason. Okay. What's the second term? Okay. So second term is, what's the second term? There's r, but then maybe I should get the letters out. Drop the book up, make sure I have the same letters that they use, but it's r. Remember, this is a Taylor series, and r is just a constant. R is 3/5 in this case, right? It can't just be r. So what's the next term? Who knows the next term? I'm not seeing it's Rx or Ru in this case. And R is 3/5. Oops, 3/5. And then times U. Again, everywhere in the formula that I see an X, I write a U. And everywhere in the formula I see an R, I write a 3/5. Any questions so far? Okay, what's the next term? So plus. There's going to be a u squared. It's not -2/5 only, because it's r times r minus 1. And r is 3/5. Times, and then r minus 1 is -2/5. And I'm going to put the negative outside. Nope, I didn't think it would work. I have to go to fraction. 2/5. And then over 2 factorial. And then times u squared. Any questions? Have I lost anyone there? Okay, and you could write it as 6/25. Remember, we're looking possibly for patterns, so I think it's easier to not write it as 6/25 as to write it as it is now. Okay, now let's go to the next term. So it's plus, and then we're going to have a fraction. And then remember, you start with what you had and you add an extra. So it's r times r minus 1 times r minus 2. So what I'm going to do is I'm actually, instead of doing it this way, I'm going to copy and paste this guy and adjust. A little easier. So we get -3/2 times 2/5 times what?
3, right?
3?
No.
3. We're supposed to take the -2/5 and then subtract another 1. You get -7/5, so the negatives cancel. And you get 7/5. And then the 2 factorial becomes a 3 factorial. And the u squared becomes a u cubed. We're getting there. Let's do the next one, because you may not see a pattern yet, but you hopefully in the next one you'll see the pattern. So plus, and then, so the idea is now you're going to have a 3/5 times -2/5 times -7/5, and then subtract another 3/5, and you get a, actually, no, I think, let's see. Yeah, subtract another 5/5 is what I meant, and you get a -12/5. I'm going to pull the negative outside. And then the 7, and then we get a -12/5. So we have 12/5. And then the 3 factorial becomes a 4 factorial. And the u cubed becomes a u to the 4th. Any questions so far? Okay, so now what we can do is we can look at it and start looking for patterns. So notice the 5s. That's a 5 to the 4th. You see that? So I can now, I think I'm going to do the next term, but I'm going to write it in more pattern form. So the next term is going to be plus. And then what we're going to have is the bottom now is going to be 5 to the 5th power times 5 factorial. And the top is going to be 3 times 2 times 7 times 12. Times 17, because we're adding 5 each time. And then u to the 5th. Any questions so far? Okay, the hardest part, there's 2 hard things, I think. One is to like understand the formula and just know how to plug in. That's all I'm doing is I'm just plugging in. And the other, which is more of a deeper hard part, is to look for patterns. So now we're going to go plus dot, dot, dot. And now let's look for patterns. Well, notice what we've got, at least after the third term, we have a negative, positive, negative, positive. It's an alternating series. Any questions on that? So we're looking at an alternating series at which if you have an even, you get a negative number. And that makes it a -1 to the n plus 1. Any questions? Any questions on how I got the n plus 1?
Is that
for
because it's not alternating for the first two terms?
Yeah, so the first two terms we're going to separate out, and we'll do that at the end. Does that make sense?
Yeah.
Yeah, first two terms are kind of a mess. Or you could just say the first term, because it does alternate. If you start at the second term, you're good. You have plus, minus, plus, minus, plus, minus. Do you see? You have -1 to the n plus 1. Then we're going to have a fraction. I think the denominator is the easiest, because that's going to be n. That's going to be 5 to the n. Then you're going to have n factorial. Please stop me if there's something you don't understand in the process here. Okay, and then let's see what we've got here. We've got the 3 just hangs. You see that? So that's just going to be 3. That's just like a little extra. And then times 2 times 7 times 12 times dot, dot, dot. And now the idea here is the 17 is what we did is we took this 5 and we multiplied it by 3 and added 2. So we're going to go 5 times, and then the 3 comes from n minus 2 plus 2. You could also do 5 times n plus 3 minus 3. That's the same thing. That's totally your choice.
So is that the only way to write? Basically, we're adding 5 each time?
Yeah.
Okay.
Well, when I say the only way, it's not the only way. Because remember,
Okay.
I just said there's a second way. You could also write 5. You could also write 5 times n minus 1 minus 3. That's totally your choice. And hopefully you agree that's going to be the same thing. Any questions on that? And then times u to the n. Any questions so far? It's messy, but it is what it is. Okay, so now let's put everything together. And what we can now do is say, well, u is -2x. Do you see that? So that means that we're going to have a negative out of that. Is that clear? So the good news, first thing, let's just write down the first term, which is 1. I'm going to need to copy this so that we can replace what we need. And now we're taking our u and making it a -2x. So we're just substituting. So the first thing is we're going to have a 1. Again, that's just kind of like an unusual one because it does weird stuff. I mean, it doesn't fit with everything else. Okay. But then after that, it fits with everything else fits. So now I can get rid of everything else. and I can write plus, and now I can write summation. And we're going to go sub n equals 1 to infinity. This is where you got to put in the n equals 1, because normally you say n equals 0, but the 0, 1 is a special case. N equals 1 to infinity. And now let's take a look. We have a 2x, we have a negative 2x to the n. But the negative 2x to the n is negative 1 to the n is, sorry, 1 to the negative 1 to the n times 2 to the n times x to the n. So negative 1 to the n times negative 1 to the n plus 1 is just negative 1. So that's just negative. Anyone lost on that little negatives? Because you get a negative 1 to the 2n plus 1, but negative 1 to the 2n is 1. So you just get negative 1 to the 1 is left over. The numerator and denominator stay the same, except what you end up getting is that the 2x to the n becomes a 2 to the n. And then the u becomes an x. And then I'm done. Any questions at all on this problem? So binomials are pretty messy. They're pretty messy. And you got to get used to factorials, and you got to get used to powers and sequences and patterns and all that. But, you know, this is the very climax of the entire year. So you're all super experts at this point. Up to a point. I know this is hard, and my guess is some of you didn't get it right, but at least you got it started. That's the hope. At least you hopefully noticed that it was a binomial. Okay, the next one actually, the funny thing, next one looks harder because you're integrating something impossible, but it's actually much easier. So we want to use power series to integrate e to the 2x over x. Okay, the first thing, by the way, what would happen if you tried to do it using last quarter? You know, finding, you know, u substitution or inverse trig or something like that. You don't know what would happen?
No, I don't.
The answer is you would just give up. You can't do it. Okay. I hope nobody tried to use last quarter's stuff, because you can't do it. This is one of these impossibles. But with power series, you can do anything. As long as you can take derivatives, you can do anything. What we need to do is we need to find the power series for e to the 2x over x. So let's write down e to the 2x over x. And the key on this one is I'm going to take that over x. I'm just going to pull that outside. So 1 over x times the summation. Now, the hope is you have e to the x memorized, because that, remember I told you that's the most important power series of all power series, and nothing's even close to its importance. So that one you should know. So the idea is e to the x is x to the n over n factorial, and e to the 2x, that's the same thing as, let's write this down. So now we're going to have, instead of x to the n over n factorial, now we got a 2x to the n over n factorial. Any questions so far? Any questions? So what I did is I plugged in 2x where I see the x and the x to the n over n factorial. Nothing too fancy here. That's equal to, I can bring the 1 over x in, so let's do that. Summation of 1 over x. And I could take the 2x to the n and write it as 2 to the n times x to the n. Any questions on that? We're getting there. Okay, so now what I want to do is I can say that's equal to, how do I put the 1 over x and x to the n together? How do I merge them? I still have a 2 to the n. And what do I get? Yeah, x to the n minus 1. Any questions on that? Any questions? Okay, let's put that in the question. Okay, so we now know that. So now what we want to do is now we want to integrate. I think I'll copy this one actually. And then adjust. So we want to integrate that guy. But the idea here is that the integral of a sum is the sum of the integral. That's a big theorem, which I didn't prove. Oh, did I forget the n factorial? Yep, thanks. I left it out. I had it and then I lost it. So now we have the sum of the integral of 2 to the n over n factorial x to the n minus 1 dx. I guess I didn't write the dx. And you should write the dx because otherwise it's not clear whether you're talking about n or x as your variable. So dx is important. Okay, but the good news is that's an easy integral. Unlike the original integral, this one's easy. 2 to the n over n factorial is a constant. What's the integral of a constant times x to the n minus 1? What's the integral of a constant times x to the n minus 1? I don't see y'all jumping in. Yeah, it's going to be the constant x to the n over n, except you're forgetting something. Remember the old lose 1 point? Yeah, plus c. So you have that, and I'm going to put the n, since it's in a denominator, I'm going to leave it in the denominator there, times x to the n plus c. I think I lost the n factorial in this one, so I think I'll put it in. So we have it right. There we go. Any questions at all on this? Any questions? And this is an indefinite integral, so don't even think about like trying to find the constant, because that you can't do. Any questions on that? Okay. Just a note, and let me show you kind of probably a better way to write it, even though technically it's the same. Unlike last quarter, it's usually better to write the constant first. And the reason for that is that the constant's not inside the sum. Otherwise, you should technically have parentheses around the sum part. And we're not adding c plus c plus c plus c plus c, then you just get infinity. So this way you know that we're good. Any questions on that? Any questions? And that is it, actually. So that is your last quiz of this whole year, actually. I know first quarter you didn't get them because you didn't have me, but it's the last quiz you get with me. For good, hopefully. Any questions at all on this quiz? Any questions? I'll give you a minute to think about questions. We have time. I'm going to get my other computer out so I can be looking at the test. Any questions? Okay, I guess I should, even though I didn't do it. I don't have like an agenda of topics to cover to show you new stuff because there is no new stuff. But I'll still need a whiteboard, so let me just pull the whiteboard. Let's do, this will just last the class from the other class. You don't have to look at that. So all I have is quiz, in terms of my agenda. There's not a lot of agenda and exam review.
I have a question for you.
Sure.
You know how you said with functions that we couldn't integrate before, when we use Power Series, we can integrate them now? Does that account for every function, even ones we do know how to integrate?
Sure. So for example, e to the x. Let's do it. Since you asked, it's a good question. So the integral of e to the x. Okay. By the way, you better know how to integrate that. If you don't, I'll be disappointed. So if you want to do the integral of e to the x, dx. Well, that's equal to the integral of the summation of x to the n over n factorial, right? Dx. That is equal to, you can switch the integral and sum. I'm going to do it in one step if that's okay. And that's going to be the summation of x to the n plus 1. Actually, I'm going to write down, before I do that, I'm going to write c plus the summation of x to the n plus 1 It's a really good question. Over n factorial times n plus 1. Any questions on that? All right, but what is n factorial times n plus 1? Oops. So what is n factorial times n plus 1? That's the key to this.
Doesn't that depend on what n is?
No, but what in general, what is it? Here's the hint. Think about n equals 5, for example. That's 5 times 4 times 3 times 2 times 1 times 6, which is the same as 6 times 5 times 4 times 3 times 2 times 1. So what's n factorial times n plus 1?
It's n plus 1 factorial.
Yeah, n plus 1 factorial. Is that clear? Okay, but now if we kind of let, I don't know, w equals n plus 1, that's the summation of x to the w over w factorial. You see that? And that's e to the x, isn't it? That's a lot of work. to integrate e to the x, but it works. Is that clear?
Definitely.
Yeah. So here's the punchline. This is why I wanted to do it for you. The punchline is the answer to your question is absolutely. You can always use power series to integrate anything you want, but there's a punishment. And what's your punishment?
All this work.
Exactly. So if you have an easy integral, do the easy integral from last quarter. Nobody would even think about using power series to integrate e to the x, okay, or e to the 2x or sine of x or any of those kind of things. On the other hand, if you have one of the impossible integrals, always use power series.
Okay.
And that's kind of the punchline. Now, there is one small caveat, and that is that you can never use power series if you don't have a nice function. And nice means you better be able to take derivatives forever, which again, that's basically any function you've ever met in your life. But there, so it's a caveat that you'll probably, unless you become a math major, you'll never have to worry about. Does that answer your question completely?
Sure does. Thank you.
Okay, great. Good question. Other questions? What I'm doing is I'm opening my screen from my other computer so I could look at the exam and talk about it without showing it to you. So if I look the other way, that's what I'm doing. Ask questions if you have them while I'm opening it up. Any questions? Okay, so I have the exam open. Okay, if you just had supercomputers like hacking skills, and you could look at the exam, but my guess, I don't even know how to hack this, to do that, to have a computer next to a computer and hack into it. But here it is. So I'm looking at it. I'll try and look at, if I don't look at your screen, I know the voice dies. So let me know if I accidentally be looking at the test and talking, trying to go back and forth, which is not that easy. Okay, so the first thing is, when does the test start? What do you think? You should know this. What time?
8:30.
It's 8:30. It's not 8:35. It's 8:30. I don't do an introduction for the test. You just go take the test. So I'll let you know there isn't going to be a Zoom session at all on Wednesday. So don't go into Zoom, because I won't be on Zoom, because what I learned my lesson. I think it was from the stats class when I learned the lesson, is that if a student is in Zoom, then they have all kinds of problems with Proctorio. So don't even try to get onto the Zoom on Wednesday, because again, I don't want to create nightmares. So, but I will be on email if you have, if you for some reason can't get in. Does that make sense? Or if Proctorio is just messing with you. Okay, so I will be on email, but I won't be on Zoom. Got it?
What
I
do we
learned my lesson that if I'm on Zoom, it can mess everyone up if you try and get on too. So I'll be on email and I'll be checking, at least for the first half hour. I'm not sure if I need to sit there looking at a computer for 2 hours while nothing's happening. I don't see any reason for that. I think I'd be wasting my time. But for the first bit, I'll definitely be on in case there's any issues. Usually once you're in for 15 minutes or even a minute, there's no problem. Does that sound right for those of you who took the first test? Once you got in, you were in, and there were no problems after that.
Yeah, that's about how it worked out.
Yeah. It was only a couple of you that had trouble the first time. What do we do if it's not letting you in? You had a hard time last time. So the one thing is, whatever ended up working last time is what you should do this time. Whatever didn't work last time, don't do that. So that's my only suggestion. Something must have worked, because you all took the test.
I had a problem on the last exam where it, like, keep kicking me out.
Mm-hmm.
it would like,
And what'd you do to fix it?
I didn't do anything to fix it. I didn't have any windows open. I like restarted my browser. I was afraid to restart my computer because I was like, I don't know if I can rejoin. Like I had to refresh the page
Mhm.
and like go through the whole like show your ID card, show your room again about like 5-6 times, and doing it takes a bit of time to do that each time. I would like go about like it happened near the end of the exam, and
Really?
like it probably took away 45 minutes.
I'm sorry about that.
Yeah.
Again, I'm new to this too. I think you get that right.
Yeah, I'm not blaming you by any means. I was just, I mean, like if something like that happens, like I don't know, what should we do?
Well, obviously keep trying to get back in.
Well, yeah.
And it happens a lot. Drop me an email.
Okay.
And again, at least the first bit I'll be watching. It's just painful to stare at an email for 2 hours and nothing's happening. You know what I mean?
No,
I don't get emails. So I don't know if I'm
totally
going to sit there for
understand.
2 hours staring at my computer looking. But I'll be checking.
Yeah.
And that's the best I can do. Again, it's a hard one. I just wish we can get back, but I don't think we're getting back. It'll be bruised.
Well, yeah, I mean, I don't know as much as I don't know what you could do, but like I definitely could have used that time to like check my work and go over some stuff. So like I don't.
Right. See, I could, had you asked, it's too late now because the test was a long time ago.
No, yeah.
Had you asked, I probably would have given you extra time.
No, yeah, I think I didn't want to send an email as well because like it checked. This
Right,
time I
because it
won't.
tells you, because then it gets mad that you'd sent an email. It's a
Yeah,
hard one. I don't have the
yeah,
greatest.
yeah,
If you
I
can't
mean,
get it
this.
at all, send me an email for sure.
Yeah, I think that, I mean, this time I know I'll definitely just be like, hey, I'll send an email. And then knowing that you get the email saying what I sent, like, it's not going to be like, oh, yeah, he was looking up some other stuff. But, so yeah, I guess I'll make sure to just do that next time.
Hmm.
Um,
Yeah. And like I said, if something worked for you, do what worked, obviously.
Yeah, I really just don't know what happened because like it only happened at the end of the exam and it was working all up until then, and then like the last probably 2 hours of the exam it would like just I don't really remember too much, but it would just like keep intermittently, like I didn't think it was like a consistent time frame in which like every 10 minutes would kick me off. I don't think it was like that. I think it was pretty random.
Just when it felt like it kicked you off.
Yeah.
I really have no idea. I mean, it could have been internet issues.
Yeah, I really don't know either. I was just wondering like if it did happen,
Mhm.
what should we do? That's all I was really wondering. But
Yeah.
just to
Um,
make sure that's good.
Yeah,
Okay.
you could email me and I could come up with some plan B. I could be
Okay.
flexible. I'll let you know that.
Okay.
But don't email me in August, okay?
Yeah, I'm not. Yeah, no.
Yeah, make sure if you do email me, it's right after the test, and then I could at least help you out. Okay?
If it's happening during the test, like if it happens during the test, can I email you during the test, or should I just wait till
I think
after?
Proctorio won't let you.
Oh, okay.
I think it freezes the screen. I have it set to freeze the screen.
Okay.
Yeah, so I don't think you even can.
Okay.
So that's the bad news.
No, it's all
Yeah,
good.
I wish I had a good solution, but I don't. And if anyone else has a good solution, let me know. I'll try it. But I don't know. Like I
Yeah.
said, the solution is a vaccine.
No, yeah. Yeah.
So we'll see. Hopefully next quarter there'll be one. And we'll be able to get back. But who knows? Right now, no one knows what's going to go on. Right now, we are planning on not being on campus next quarter. So that's the bad news. Unless it's except for lab courses and only some lab courses.
Yeah.
But
Is there
math
any-
courses are planning on not being on. And I have no say in it. Just let you know. So don't shoot the messenger.
No, yeah. Is there any word on UCs yet? Because I don't think
I
they've.
haven't heard the UCs, and I watch the news a lot. There's
Yeah.
no announcements on the UCs. The Cal States, though, are completely closed. Community colleges are completely closed. So that's for sure. And then hit and miss on the privates. Okay. So again, I apologize, but most of you actually were able to get through Proctorio without problem. And I know some of you had issues. The other possibility is to get a college computer. Those of you who had troubles were using a college computer or your own computer?
I was using my own computer.
Yeah, and I'm not sure if that's a complete solution because if it was internet, then the college computer won't help. Does that make sense?
Yeah, I mean, it still may be worth a try.
Yeah, but it's all or nothing. That's the problem.
Yeah,
It's not like you try and then go back to your computer. It's like once you're on, you're on. You can't
Yeah.
switch computers.
yeah,
So if you eventually took the test, then maybe it was, at least kind of worked. Okay. But and I think everybody took the test, so I don't think anyone has to have a college computer. I know a couple of you got a college computer because of the practice ones, you couldn't make it work. Okay, so sorry about that. Again, I don't have a good solution. I wish I did. And I've talked to all my colleagues at LTCC and other colleges. None of them have good solutions either, by the way. So it's nobody knows because we're all dealing with it. So sorry. Let me talk about the test. So that's the first thing. It will be Proctorio. It's exact. I just did copy and paste on the Proctorio settings. So it should be the same settings, which might be a headache. I can't do much about it. But the exam itself, there are some things that are the same. Question number 1 is the same as question number 1 on your first exam. Who remembers?
Write your name and promise not to use any outside resources.
Yep, and that's the same thing. And by the way, I guess I'll talk about it Friday, but final 2. Okay, and I got that as a suggestion from my colleagues out from other colleges, actually, because they said that helps some. Not perfect, but, at least then you signed it, your statement. So I did that based on the suggestions from other people. So that's number 1. So let me tell you about the rest of it, because I don't think I have to explain how to write your name. At least I hope not. Okay, so I'm going to be moving my eyeballs to look at the rest of the test too. Okay, question 2 and question 3 starts with the following. And you're used to this. What do I always ask on tests? Just about always, most of the time.
True or false?
Yeah, this is a true false. And I want to remind you, let me read what it says. Please answer the following true or false. If false, explain why or provide a counter example. If true, explain why. So I want to really get into the details because some of you didn't get it on the first exam. If false, counter examples are fine. If true, examples are not fine. Got it? Okay, to give an example where it works is not a good answer for the true falses. Is that clear? So if true, then explain why means it might come from a theorem. You could say by this theorem, then it's true. Or it might come from a little algebra and you get something true. Does that make sense? Okay, if it's false, then an example is okay. And that's actually called logic. Okay, to show something's false, an example always is okay logically. To show something's true, an example is never okay logically. Is that clear to everyone? Okay. And you do your best on the true falses. They're conceptual, of course, and see how you do. Any questions on questions 2 and 3? Okay. I thought that's what I do today is I go over what the test is. And then you guys, if at the end, if you want me to do some examples or have you do examples, that'd be better. And then I'll show you if it's right or not. We can do that because I can make up problems. The good thing is I've been teaching this class for a quarter century, so I can make up problems off the top of my head without a problem. Okay, question number 4 is determine the radius and interval of convergence for the following series. Be sure to state what test you're using. Okay. One of the nice things about this particular exam and what we've done since the last exam is it's built on itself. So by giving you this question, I'm actually giving you the last chapter. Do y'all agree? Because you're doing tests for convergence. So that means I can make my exam a little shorter, or your exam a little shorter, because I asked this question, I don't have to do quite as many tests for convergence questions. Any questions on this question?
This was number 4, right? Or 3?
Question 4. Because remember, there are two true falses, and then write down your name. So we're on 4. Okay, so who remembers, because I wrote it down in the webinar, webinar like a couple weeks ago. What are the steps in finding the interval of convergence? What's the first step? Remember, there were 3 steps. And who remembers the first step in finding the interval of convergence? Hasn't been that long. You remember?
Use the ratio test.
Good, good. Actually, a couple of you simultaneously said that. So step 1 is to use a ratio test. The ratio test will give you the radius of convergence, by the way. Okay, and it'll give you the interval without knowing the endpoints. So what's step 2?
Use any of the given tests that we previously have used to and for the left endpoint to see if
Good.
it converges, and then the step 3
Great.
is
Well,
the
let's
same.
go step 2. Step 2, one at a time.
Okay, sorry.
So step two is to use other tests. Sometimes it's going to be couple tests, by the way, to determine whether the left endpoint converges. And what you do is you plug in that left endpoint value so you don't have any x's anymore. And then you're back to the prior chapter. And what I'm saying, sometimes you have to do more than one test. Sometimes you do a comparison test, and then you're comparing with something that needs a test. And sometimes you don't have a comparison test, and then you just do a single test. So maybe one test, it may be 2 tests. Okay, so that was step 2, is get the left endpoint. What's step 3? And that's obvious. Yeah. Step 3 is the right endpoint, which is basically the same idea. And I want to let you know it's not always the case, but I'd say over 90% of the time, one of them is going to use the alternating series test, and the other is not going to use the alternating series test. Okay, and again, whether it's left or right, that is totally random. Sometimes it's left, sometimes it's right. But alternating series is almost always one of the tests you use. I mean, a test you use for one of the points. And that's because one of the points is going to give you a -1 at the end, and the other one won't. Any questions on question 4? Okay, so question 5 is you're going to have to find a Taylor series. Okay, so we've been doing that. Not in this assignment, but a couple last assignment before, is you're going to have to find the Taylor series for a function given. Okay, is that clear? Now, there are 2 different approaches, and I'm not even going to tell you which approach you're going to do. because I want you to know both approaches. One approach is you do what I call the H table. So you do a table with n, the nth derivative of x, and the nth derivative of f at c. Okay. The other approach is you use one of the Taylor series you already know, and then you do adjustments. Is that clear? Okay. And I want to mention also some vocabulary. If I say Maclaurin series, what does that mean?
It's centered at 0.
It's centered at 0. So some vocabulary that you're responsible for knowing. Any questions on that? Okay. So that's a note. You're going to have to do, one of those styles. And I'm not going to tell you which, and it might be Maclaurin, might be Taylor. If it's Taylor, I'll give you the C. If it's Maclaurin, I don't need to give you the C. Any questions on that? The second approach is to take a series that you already know and then adjust it. So things like geometric series, or e to the x to the n over n factorial, or, right, I wrote a few, sine of x, right? The sine of x was x to the 2n plus 1 over 2n plus 1 factorial times negative 1 to the n. Okay, and cosine of x, that was the even one, so that was going to be the negative 1 to the n times x to the 2n over 2n factorial. So there were a few that, you should just know. Not too many. Any questions on question 5? Okay. Question 6. Okay, so what I'm going to do is I'm going to have you, again, I'm not going to give you all the details, but some of the details. I'm going to have you first find either Maclaurin or Taylor series or a function, kind of similar to the last question, the question 4, but then there's a part B on this one. So the part B is to do calculus. So what are the 3 calculuses that you could do?
Derive, integrate.
So differentiate, integrate, and?
Multivariable differentiate?
Huh? No multivariable differentiation in this test. That can't happen. That we haven't covered. I will tell you there is such thing as multivariable power series, but that's not this class. That's advanced. Yeah, Victor's got it. Limit, because those are the 3 calculus things, right? Limit, derivative, and integral. What I'm not going to tell you is which of the 3. I want you to know how to do all 3 of them. Okay, but it's going to ask you for one of them. Any questions at all on that? Okay, for the next one. I'm going to ask you to determine, let me just read it. I have to keep moving my head because I got 2 computers. For each of the following series, determine whether it converges, absolutely, conditionally, or diverges. Be sure to state the theorems you're using. If it converges, determine how many terms are necessary to ensure that the error is less than a certain amount. I'm not going to tell you much. If you approximate it with the corresponding finite sum. So this is the alternating series stuff that we did. Do you remember doing those? And remainder theorem also. Any questions on that problem?
Sorry, could you repeat that a little bit? Like when you The audio is kind of weird when you like look towards the screen. It kind of gets muffled, like your other
Yeah,
screen.
sorry about that. I don't have it memorized. I have to look.
No, it's all good. I was just wondering if you could
For
repeat it.
each of the following series,
Yeah.
determine whether it converges absolutely, conditionally, or diverges. Be sure to state the theorems you're using. If it converges, determine how many terms are necessary to ensure the error is less than a given amount, which I'll give you. If you approximate it with the given finite sum. So that was the remainder theorem, if you remember, for alternating series. Okay, but you also have to be able to test for convergence. We did a lot of testing for convergence, so don't be surprised if you're going to do that a lot. Any questions on that?
What question number was that?
7.
Thank you.
And how many series are there going to be on that?
Try to remember 2 or 3, but it doesn't matter because it shouldn't affect your studying. Do you agree?
No.
The reason why I don't remember is I think I cut it. I'm looking at an older version, I think, but I'm not sure. So, but again, if it doesn't affect your study, then I don't feel guilty.
And the practice exam is up, right?
Yeah, I think there was a practice exam. Yeah, I think the practice exam was just an old exam I gave from before. The good thing is that this stuff is the same, you know, whether we're doing it Eve or with a different book or whatever. Math is math. That's the good thing. So I think I wrote the practice exam 23 years ago.
Yeah.
24 years ago. Might have been the first exam I ever gave. Okay. Question number 8. Okay, so here I'm going to ask you to find a Taylor polynomial at a given value of x to approximate a function. I'm also going to ask you about remainder. So hopefully you know how to do that. And this is not, I will tell you, this is not going to be one that you're supposed to recognize and have memorized. This is one you do it from brute force for sure. Because it's just a, you know, a Taylor polynomial, not that, it's not an infinite series or anything like that. Any questions on that?
You said find the Taylor polynomial and what else? Remainder theorem?
Taylor's remainder theorem. Okay, question number 9. Question number 9 is, I think I'm just going to tell you, you're going to have to find a series given a function. And then question number 10. And 10 has a few parts, 2 or 3. And that is determine if the following series converge or diverge. Make sure you state which test you're using. So that's the prior chapter. And that's question number 10. And that's the test. So it's technically a 10-question test, but I don't count question number 1 really. So it's really a 9-question test. I mean, saying write your name, I don't think that's a full question. Hope you all agree.
Question 9 was find the series given a function. And then number 10 was determine if the following series converges or diverges.
Yeah. And
state the given test.
There shouldn't be any surprises. Are you surprised about any of these questions I said?
No.
No.
Yeah, this is very standard material. Okay, there's nothing fancy. Even the homework problems, you've had very few fancy homework problems. Have you noticed that?
Yeah, I actually was noticing that. I didn't see very many applications as of.
No, and the reason is the applications are truly upper division.
Mm.
Not because there's no applications,
Yeah.
but like if you don't understand quantum physics, then there aren't a lot of applications of physics. Does that make sense?
Yeah.
And quantum physics is not community college math. So this is to get you ready for advanced classes. And the problem is that if you don't know advanced stuff, you won't use power series. Does that make sense?
Yeah.
So even for me to explain the applications would be over your head. Okay, whether it's math applications or physics or whatever. Okay, so differential equations is a biggie, but again, you don't have enough to understand the differential equations yet. You know, full circuit analysis stuff uses this. There's a lot that uses it, but it's too advanced. So that's why this quarter, and sorry about that, doesn't. These two chapters don't have any applications to show you. Not because there's no applications. It's because this is for advanced work. Okay, any questions at all on what to expect for this exam? Okay, I do want you to know, and hopefully it's okay because I can change my mind if you want me to change my mind. Originally, I wrote the exam and I had second thoughts. I realized it was probably too long, so I shortened it, but I'd written the key to the longer version. And what I decided, and again, if you don't like it, I can change it, is to keep the key as is, even though there's going to be some problems on the key that are going to be posted after you take the exam that you didn't get on the exam. Are you okay with that? And that
Yeah.
way you get to see more practice problems for the final.
Yeah, that's cool.
Because I figure the whole point of the key is to study for the final. Don't you agree?
Yeah.
So I thought having a key to more problems is better than having a key to the shortened version of the exam that you're after taking. So when I post the key after everyone's finished taking it, because that's what I'm going to do, right? Right now, you know, it's not visible to y'all. But when I post it, don't be surprised if you see problems that weren't on the exam. Does that make sense? And that's just because when I wrote the key, I'm like, this is too long. You're going to hate it. Shorten it. So it had a couple extra problems. So, and since I'm not going to be like talking to you again in a webinar between now and when I post the key, I figure I better tell you now so you don't get all confused. Okay, does that make sense? Okay, and then what I'll do, by the way, after you take it, and there's a group that has accommodations and they finish a little later. So I have to wait until everyone's finished pretty much until I start grading it. But I will grade it by Thursday for sure. It takes me a long time because I got to write a lot of comments so that you guys can see comments. And typing comments is a lot longer than writing them on paper test that we did last quarter. So, you know, it's not going to be immediately, just it takes forever to write them all out for each person.
I have a question.
Yeah.
Are we going to be meeting on Friday and next Monday?
Yes and no. So yes, we're going to be meeting on Friday because that's in the calendar.
Mm-hmm.
And Friday is but that's a good question because let me talk about that. Because again, everything's different now that we're done with the class in terms of new material. So there is no quiz on Friday because what would I quiz you on? Do you agree?
Mm-hmm.
So there's no quiz on Friday. So we're going to meet at 8:30 on Friday, and I'm not going to be turning off Zoom at 8:35. We're going to meet on 8:30. We'll talk about the whole class. I'll talk about the final. I'll go over the exam a little bit because going over the midterm this exam will help you for the final. Does that make sense?
Yeah.
Because you're asked similar questions. You know, some of this similar questions. So I won't go over this. I'll go over the key is what I'll do. And we'll go until 10:15. You know, Monday is not a class day. Okay, I do have office hours Monday, but we don't have class because it's not in the calendar. And I'm not supposed to just make up classes.
Okay.
I could do a Sunday class if, but I'm not going to. So Monday, there's no class, but a week from Wednesday is your final. Does that totally answer your question?
But
That's a
you'll
good
still
question, though.
host office hours, you said?
Yeah,
On Monday?
I'm keeping the same office hours. I don't know if I'll keep the same on Wednesday because it doesn't make sense because you'll be like taking your test.
Yeah, definitely.
Yeah. I don't know about Wednesday. I'll have some office hours, but it's not for you guys because you'll have finished the final. Once you finish the final, there's no reason to come to office hours. Right? So it's more for my stats class, which is Thursday final.
Okay.
But Monday, Tuesday, I'll definitely have office hours. And I might have my office hours Wednesday, but you'll be taking your test, so don't try and go to them. Other questions? These are good questions, real important. Other questions? We have a little time left, not a huge amount of time, but a little time if you want to see example problems, or if you want to call it a day, we can do that. Or you have questions, whatever, I'm here for you. Oh, that's a good question. Is the final at 8, not 8:30? Let me check. Because it is what it says. Whatever it says in the syllabus. So I think what I do, oh shoot, not that one. Let's do this. Okay, so the final, I think it says, yeah, the final is actually a weird time. The final exam is 10 to 11:50. I don't set the final time. If we have a unanimous decision that you want to be 8:30, I could do that.
I like 10.
I am perfectly okay with it staying at 10.
Yeah, same.
Okay. Like I said, I follow what the college tells me I'm supposed to do. But the rule is if we have a unanimous agreement, then I can let that happen. For things like final times. But what I can't do is do it when it's not unanimous and say, oh, I'm sorry, even though the college says I'm supposed to do it, I'm not going to, and you're screwed. Does that make sense?
I say nay on changing the final time.
Okay, so if one person says nay, which we got, I feel a lot of people say nay, it'll be 10. But I might change it if you say yes to make it 10 to 12. Would you rather have 10 to 12 or 10 to 11:50?
I could potentially agree with that.
To give you a little extra time if you need it. You can always quit at 10, 11:50. But make it a 2-hour if you need it.
Yeah.
Final's already written, so it's not like I'll be, changing
10 to
it one
12
more
would be
time.
awesome.
So I think I'll make it 10 to 12. Just to make more sense. And usually when you take my final, I give you an extra little bit of time anyway during the final. The only problem is if you have another final at 12, which most people I doubt, they don't usually schedule it that way anyway. That could be a mess, but yeah, for the second exam, that's a good question. Let me see something. Yeah, we already talked about the second exam a long time ago. It goes till 10:30. So Wednesday goes till 10:30. Okay.
That's
So
cool.
8:30
Thank
to
you.
10:30. Yeah, no, we're gonna keep it 8:30 to 10:30. So 2 hours is definitely enough, unless of course you have accommodations, and that's a whole different thing. Okay, other questions? These are good questions, real important. Other questions?
Could you do like an addition or subtraction problem with summation?
With power series, you mean?
Yes.
Okay, just want to make sure that's what we're talking. We're talking the same thing. I want to go there. So, I'll let you choose, add or subtract.
Subtract.
Okay, so consider power series. It's a lot easier than you think. F of x equals a summation. And I'm not going to write it out, but if I don't write it, it means n equals 0 to infinity of, how about x to the n over n minus 1 and g of x equals a summation of x to the n over n plus 1. Just making something up. You know what? That can't be n minus 1. Sorry about that. Make it n plus 2. Because if it's n minus 1, then you have problems at 0. That way, don't. Find the power series for f of x minus g of x. Is that kind of what you want to see?
Yes.
Okay. And the idea is that this is pretty easy. So if we want to find the series for f minus g, all we have to do is put them together. So we're going to have a summation of x to the n over n plus 2 and I think I'll stick a parenthesis minus x to the n over n plus 1. And then we can just factor out the x to the n. You have to get extra credit on the sex exam. The answer is no. That's only for the first exam. I just noticed that in the chat box. So summation of parenthesis 1 over n plus 2 minus 1 over n plus 1 x to the n. And if you want, you could pretty it up and you can write that as a summation of fraction. And then we can write that as negative 1 over n squared plus 3n plus 2 x to the n. Do you understand what I did there?
Yeah, you just like got a common denominator, didn't you?
Yep. I figured I might have done a little more in my head than you would do in your head, but I figured that was just basic algebra. You can do that, right?
Why is it not on the numerator either?
Let's see, when you're saying it, what do you mean by it's not in the numerator?
Like to find the common denominator, don't we need to multiply both numerators by the opposite denominator?
Yep. And I think I did more in my head than you can do. So I wrote n plus 1 minus n plus 2. which is
Mhm.
-1.
Oh yeah, you're right.
So sorry if I
it.
did a little more in my head than you guys like to do, but I decided that was basic algebra, so I didn't think I'd
Got it. Thank you.
writing it all out. Yeah, so I promise you I didn't do anything other than basic algebra on that step. But messy basic algebra. Any questions on that? Okay, and there you go. Now we have a series. Okay. The interesting thing is that at x equals 1, for example, the right-hand side converges. And why does the right-hand side converge? See if you can tell me the test, because it's important. If you look at -1 over n squared plus 3n plus 2, x to the n. Why is that convergent when x equals 1?
Isn't that P series?
It's kind of p-series. It's a limit comparison test
Mm.
with the p-series 1 over n squared. So it's two different tests. On the other hand, if you look at the f or you look at the g, they both diverge at n equals 1. Do you see that? And why do they diverge? This is a good review.
Harmonic series test.
Harmonic series test along with the limit comparison test, where you're comparing with the harmonic series 1 over n. So this is where you got to be careful, just because you have two series that convert, that just because the subtraction of the two things converge when you put them together does not mean they converge individually. Does that make sense?
Definitely.
There's a nice little example that you probably, when you asked, you probably didn't even want all the depth that I'm giving you, but there's a good things to know what you can and can't do. Any questions on this or anything else? Any questions? I think I'm going to stop the share and maybe pop it at office hours, which means I'm going to stop the recording. And I hope y'all do well on the exam, but I'm here for you for the next hour or so.